All right. So we continue to work on our Linux command. One of those is, let's go back to our Python 3. Everyone's Raspberry Pi has a Python and Python 3 already. So see if we can improve ours. Okay? So bring your terminal as we did usually. And what is a Python version? Python minus version, then that is Python. Oh, if it is a Python small character, then we need to do, I believe, dash dash, double dash. So Python installed on my Raspberry Pi, there is a version 3.11. What about Python 3? That is also 11. All right, so next thing that we need to look at is apt list. Apt list, capt list. These are something already installed. So among that, I want to grab, oh, by the way, this is a pipeline. Today we'll look at the pipeline. In the next slide somewhere today, there's a pipeline slide. There you can see the formal lecture about pipelines. So apt list, then it gives us, let's see what it is first. If we want to see it, then apt, this command line interface, and see what is the option list. If you say list, that gives you here list in that it can display a list of packages satisfying certain criteria. It supports glob patterns for matching package name as well as options to list installed, upgradable, or all available version. That's what we can get from apt list. But apt list gives us a long list. If you want to get something that you want, then pipeline. So all of this will be the input to the next command, which is grab. I want to grab Python 3. Then it gives us everything about Python 3. Some of the upgradable, so 3.11. What is it?
What did you do after you grabbed Python 3?
Hmm?
What did you do after you grabbed Python 3?
No, before we do apt list.
Yeah.
Yeah.
And then after you executed that?
Correct. Yeah. Hit enter. Apt list gives us a full list of some of the installed packages or upgradable packages. So pipeline, then that goes into the next command, which is grab. Grab is to search.
Right.
I want to search the Python 3 from whatever argument after this, but instead of that XXX, we can get it from the previous command. That's what it is. If you want to get, for example, here, I want to grab what other packages that I have. Probably we didn't set up any yet, right? See if there is a MySQL. Probably not, right? Oh, there's some MySQL versions available, right? Ruby, something about that. All right. If you want to install the recent version, then you can install sudo apt install python 3. What is the current Python version?
13.
Is it 13 right now?
Yeah.
Okay, then we can do that. Sudo
3.
apt install python 3.13. Let's try, see what this guy says. This guy says cannot find the package by glob python 3.13. For that reason, we need to do apt update and upgrade, but it takes a little longer. So upgrade takes longer, so we don't do that here. Okay, to save time. Instead, if you want to see where the Python 3 is located, then you can, the command is where is. Where is one of the commands that you can find some of the resources. What other command other than where is? Similar to that is which version of Python that we are looking at. So Python 3 is in this usr/bin/python 3. Remember that location where we put our Python command, right? Aggregate that we entered into that group /usr/bin. So where, if you see where is, if you ask which, then it gives us the binary file, the location of a binary file, exact binary file of Python 3. Where is, on the other hand, gives us the all possible locations where there is Python 3 related. So for example, this is a command for Python 3. This is a library for Python 3. This is something, we need to look at this, what it is. And also here, USR share. And there is a manual also. The real compressed file, gzip file. Okay. Okay. So how to manipulate the files? First command here, tar. Tar means tape archive. Tape. Have you seen tape? Music tape? Not, yeah, like a real tape. You've seen that, right? From the museum? Real tape? Oh, music tapes? Okay. The computer data type, data tape, data records. If you want to archive it, then we put the data on a tape, real big tape. And tape is stored on the rack for the storage purpose, archival purpose. It's not backup. By the way, if you join data center, then data availability is always the issue, availability. So if you have data, then data should be always available. and your disk usually limited. So data that you think not anymore used to be used, then you need to put the data in outside. Put the data outside. That is a backup, right? But if you want to make it into a history, just only if you want it, you can bring it back, unless otherwise you push it to the backside of your storage. That is called archive. So TAR means archive. So archiving files. So we have some practice. We have some slide a little later. There we will look at this. The VCL and XVL, VCF and XVF. There's an option called X. There's an option called C. C for copy. If you want to make a copy to archive, then you need to do VCR or VCF, CVF, whatever the combinations of those. The V for verbatim, which means every time it archive, it lists that, and C for copy, F for, I believe that's for files, right? The X, that is for extraction. So archiving, then you need to put here C, actually. If you want to extract, then you need to put X for extraction. We'll look at that. Concatenating, we use that a lot, right? So far. Anything that you want to combine these two, and then redirect it to a separate file, you can do that. You can get the data, password data, and then group data separately. But if you want to put them together and get one extra independent files, you can do that. If you want to get more into this all that text file like this, then you need to have append, redirect and append together. For this, we will practice here. Okay. So if you do etc dot password file, then it gives, oh, there's a permission. So you need to do sudo Is it? No. There's a password. What happens? We have here password file. Password sudo. Oh, we have to do cat. Right. Cat etc. Then we have a password files, right? All of this above, they are already built. Only something added to my original password file is this, myself. When you first install your Raspberry Pi, you put your login ID and password, right? So there we have, I did, my login name is Jae-yoon, and colon, that is the delimiter, followed by password. But password, long time ago, when I was a student, few decades ago, password is not marked X. Password is self-shown. How nice it is, right? Although it is encrypted, but we can still see it. But now it's not. Someone may ask, if it is the case, then why don't we put it secret so no one can read it? Then we still put the password there, but we don't really do it. Anyone knows why? That password file is open to public. If you want to see that, then you can see -ls etc and come on. Okay. Password, then you can see the privileged bits here. This is so-called privileged bits. The first bit tells me whether it is a directory, whether it is a single files, and then followed by 3 each tells us who can do what, right? The first 3 tells us root can read and write, but not execute. And next 3 characters, next 3 byte tells us the group can read, but not write. And the next 3, anyone not appears here, the owner not appear here as a group. By the way, this is the owner. First number, first character, there is the owner of this file. Next one is the group where this owner is associated with. Okay, next one is the size of that file, followed by timestamp, and then ending with the file name only. So password is a file name. As you see here, this password file, usually password file should be secret, right? Should be kept secretly. But in Linux, password file, for example, if I ask you in your midterm exam, password file in the Linux is securely protected. True, false? Look at that. Is this secretly protected? All means can be read. So anyone can read. The reality of Linux file structure. The password file is not securely protected. It is open. Why? Why do you think the password file is open? So that anyone can read. It's very simple. Why? Linux is a server, right? There are more than one users. Anyone who can come in as a user should see that password file. Therefore, when you log in, you yourself comes to that password file and check where are you. For example, when I come here, my ID is 100, my group 1000. My group ID is 1000, and then there is some others. It is skipped. And what is my home? /home/jun. For example, if I do not know that, if I do not read it, then I do not know where my home is. Only I know my home is when I see that password file. So password file should be open to everyone. Some of the dilemma, right? Password file should be kept securely. That is our norm, right? Cybersecurity rule. But in Linux, in the reality, because there are some very useful information contained in that password file, so that it should be reachable by anyone. So we opened it. Instead, if there is a security, if there is a the password, then we marked X instead of showing all this marked, right? There's all password. Real password needs to be placed in the second element in this long list of the files. Second element here, just marked X. So even if you see that, you cannot see their password. Even if you see their login name, but you cannot see their password. Although you can see their home, okay, /home. For example, if I go, let's say, Christian is in my server, so Christian can come in. Then I can see, oh, where is the home of Christian? Then maybe /home and /Christina, maybe, right? But I cannot see her password. Where is the password? There's somewhere. We'll get that points later, not today. Okay, and then we can also see group. So, for example, if I say etc group, then I can see the groups. What is Jaeyoon's group? 1000. Group scanner. Group I2C. This is for IoT communications. Bluetooth. If you have that ID and some secret information, then you can manipulate it. There are some others. Right, that is that comes from /etc/group. So I can practice that. Where I am here. I want to change my directory to IASP221. I want to make my directory. From this time, I want to put, for example, today is October 7, mkdir October 7. So I have October 7, cd October 7, where I'm going to put my work. So I do sudo cat /etc/password and one more etc group together. I want to send it to all text, all.txt. Boom. Then it goes into that all.txt, right? There's all.txt. When I read it, I can see also cat all.txt. The later part of that file is from group file, and earlier portion here, it comes from my password files. So the second one is attached to the first one, right? Second one here is attached to the first one. We can do little more data extract. So etc host, and I want to redirect and append to the current file called cat.txt. Then it goes into that all.txt. If you want to see the last 10 lines of that host, I mean that all.txt files, then you need to do tail minus 10, and then file name. Then the 10 lines from the bottom will be displayed. So 10 lines from here, those are the 10 lines, right? So actually, host file contains only from here there, right? And 4 lines above are from the group files. But anyway, right now, that all that txt files becomes bigger, containing more information. Okay. Pipelining. So standard output of one command is piped into the standard input of another. This is a pipeline. So standard output, if you do this, then it will return, right? ls minus l slash usr slash bin, then a list of the executable files displayed, and that is a standard output. So standard output of the first command will be the standard input to the next command. The next command is less. Usually less followed by file name, right? So instead of stating file name here, I skip it but bring it from the previous command. So standard output from the previous command will be fed into the next command. That is a pipe. So let's practice. Some of these LSB binary file, and then also USR binary files, where there is the Python executable files there, right? ls. Well, by the way, here if you want to grab and our aggregate agg star, see if there is that files. Oh, there are so many agg. So agree. Oh yeah, 2 of those. Oh, how come 2 of those? Aggregate. And let's see. Minus L minus. Then we can see. Oh, only 1. It is by your name and my name and executable. Okay. That we can see. Now, rather than grab, I wanted to sort them, okay? So if I do sort, then it was all. Let's see, if you want to do sort to reverse, is it minus all? I don't remember, but let's try. Yeah, it is reverse, so that aggregate agg. Where is it? Oh, agg reg. What were those? Agg reg there. Like this. And if you want to do unique, because agg reg, it appears twice. unique. Then to go back a little bit, AGG, oh, still it is not unique. What is unique? Keep distinct items. It is not distinct. Oh, unique. Unique is not command. They changed. Unique is not anymore. Is it possible? No. Let me check. It is called, they changed UNIQ. Yeah, UNIQ. So previously, if we do UNIQ, then probably aggregate. Yeah, we have only one aggregate, right? So it is not anymore UNIQUE, UNIQ. Okay. Any question? Okay, now this is important from these points for today's lecture. Chaining and grouping. So if we have more than one command, so far what we did, we had somehow multiple commands there. Probably using pipelines, right? Or some command cat, then it can accommodate more than one arguments, but still one command. So more than one commands, then we can use pipeline. What if we want to do, for example, chaining? Simply list multiple commands. Then we can use semicolon. So what it does is that if you have a command 1, semicolon command 2, command 2, then run command 2 after command 1. So command 1 executed and then command 2. So regardless of success. So first command is not running, still it runs the second command. For example, if we were to, this is unique, right? Then it's not going to work. But what if we would do ls minus l usr bin and pipe grep reg, and in between I want to put here a semicolon. So when I do semicolon, then all this is a long line. This is not just simple command, right? It's two pipelines there. This is the first command. Many commands in that first command based upon this semicolon chaining. After that, we have again ls minus l, and also we have a pipeline with the grep. So in that one command, one line of commands contains multiple Linux commands where there is a semicolon. Then as semicolon enforces, this is a chaining, we need to do first one first, and no matter what the success or failure of this first command, second command will continue to work. That's what it says, okay? See what happens. Because the first one is not working because this is unique. This is not the command accepted by Raspberry Pi OS, the current version. So, see what happens. So first one is, it has failed, right? So without saying much, it doesn't stop, it doesn't halt, but the second command still continue. Because we have here semicolon, so that we have the result here, right? This is a second, the result from the second command. Result from the first command is just error messages. Oh, I have an idea. If you do not want to see any error messages from the first command, then what you need to do? You need to have a redirect, right? Number 2 goes to, maybe we can do error.txt. So it doesn't, I do not want to see here, but I want to see only succeeded output. So when I do this, then I have here, only this is a succeeded output, right? This error messages, not here. Rather, we may be able to see here error.txt. So cat error.txt, then we can see that error messages. It's the redirect. My error will be redirected. Not simply redirect greater than sign, but if we put here number 2 tells us the error. So any error goes to that file. That's what it is. It's very useful, right? Think of it. The next one is double ampersand. Command 1 to end the sign and command 2. Then run command 2 only if command 1 succeeds. Only if you have 2 ampersand, there may be that situation, right? So if you see here, instead of this, I'm going to remind you, if you do this, then we have error messages and then the regular ones. So that chaining doesn't care, semicolon doesn't care whether the first command is succeeded. And the next one is double and the sign, right? Then second command will be executed only if the first command if first command is succeeded and second command executed. So second command is not executed, right? Because of the first one is. So what if we swap those two? For example, I want to do ls minus l and then usr bin grep reg and then double and sign, which means I swap first and second. So first command here, we know this is a legal command, so it will return. It succeeds. And then the second command here, it has an error, right? So in this case, because first command is succeeds, second command anyway, it is executed. But if it returns error, it returns error anyway, right? So it'll do like this. First command that we see the result, and second from the second command, we got an error. If we swap that, it's not going to work. But in that way, it can work. Do you see that? So, very, very interesting chaining, right? Chaining of commands. If you join federal employees, or if you join one of the federal employees is military, then if you join the military, then always you have a chain of commands. Above you, you have a chain. Who is the person you directly report to? And who is above that person? Who is above that person? Who is above that person? All the way up to the president, right? The president is the utmost commander. There's a chain of a command. Similarly here, chaining Linux commands. Okay, there is this. Run command 2 only if command 1 fails. This is OR, right? Usually, if you remember the programming language, then in another, not the Python, but maybe Java, right? Java uses this operator. This is the logical commander, logical operator, logical connector, right? If the first one, in order to make this entire statement true, then both of these should be true. There is also 2 vertical bar, which means OR, similar to that, okay? So first command 1 always works, but if it works, then stop there, because entire this statement becomes true. Only first one is not true, then second one is executed. That is this. So if we practice this again, then it'll be, here, instead of AND connector, if you say OR connector, then second one will work. Let me go back here. AND connector, then second one will stop, right? It's not going to work because the first one is failure. But if you change this to OR sign, then because the first one has an error, second one will be executed. If first one is does not give an error, then second one is not going to work. Watch this. Then it'll work. First one, there's no second command operated, right? Because the first one is work. But if we add more command to make the first command to be false, then because the first command false, so second command will work when I have this here. Second command will work because first command is not succeed. Okay. Any question about this? So chaining is very useful connector. And then we have a grouping. Two ways that you can group, using curly brace or using parentheses. There are two different grouping. Okay, that gives you a very, very interesting result. Is it being recorded? I'm not sure. Let's see. Let me check if it is being recorded. Oh, thank you. I'm worrying about that. Okay. So, if you have a curly braces, then both by grouping, you can put here command. Okay, like a shell command. Inside the shell command, there are curly brace and parentheses can be used not only for commands but some others as well. So later slide shows to you. But first we'll look at the commands. Okay, if you put the commands in that grouping symbols, curly brace or parentheses. If it is curly brace, look at this. That runs on the current shell. If you have parentheses, then there's a subshell. Parentheses, then it works within that small subdomain, like environment, like virtual. It works within that small virtual. Curly brace, then it goes on top. Current shell. To get to know, there is an example. It's not really clear, right? So I'll show it to you. There is a command called I'm going to get you smaller. Okay, this is better. Okay. Let's first use this curly braces. That is the current shell, okay? Grouping the current shell. I want to CD. Let's first look at the command. CD my TMP directory. Let's see, ls TMP directory. That is on top. There's a directory called the TMP. The directory TMP contains these files. Some temporary files stored in this TMP. So I can do CD TMP, and then where I want to touch file A. Touch A, then it can create a file name, empty file called A, right? So if we see then there is A, file A, okay? Now I want to come back to my home directory. I want to group that command, cd/tmp, temporary, and then I have semicolon, and touch X, touch, so that I can create a file, okay, and hit enter. If you do parentheses, then it goes into subshell. If you have curly brace, then current shell. Two different things. Okay. If you have a curly brace, then current shell. Current shell means when you do this, if you do current shell, then you need to end with a semicolon. This is a must always. Although you have a semicolon in between, but at the end, before you close curly brace, you should always do semicolon. Then it runs as a subshell. No, current shell. Okay, this means current shell. Let me go back. Go back to my home directory, and I said this means current shell. Do you see the problem here? Not the problem, the situation. I run this program where this shell, this command, my home directory. When I done this, then my home directory goes to that TMP. Why it is possible? Because I said here cd tmp. So after the completion of this command, I am there. But watch this. Similar things. I want to come back, but I run the similar things. But rather than curly brace, I want to put here parentheses, which is subshell. If I do subshell, it means it is not current shell, but it means it is a subshell. Like a virtual. If it is a virtual, although I have here cdtmp from my home, if I did this cdtmp from my home, then at the completion of that, I am there, as it was changed. But when I do here with this parenthesis, although I do cdtmp, only what happens here inside, that is a sub. I'm still above. So I don't care. I'm still at my home. See, I'm still at my home. Although this guy said, change directory. Then it changed directory only within that sub, not current, not outside. You guys work your virtual domain there. When you done virtual domain there, then that's it. I'm still here. That's what it is. Do you guys understand? Oma.
So, using this, if you're in your desktop directory, you can use the parentheses to tell the terminal to go to the, for example,
Right, do something else.
home
Still,
directory.
right. Still you are.
Right.
I keep my home. That's what it is.
Yeah, you can execute any commands, not just, you can make it
Within the grouping.
Can you feed whatever happens inside the parentheses as a redirect into a text file, or
Can do anything, yeah.
or as a standard input into another command.
Yeah, you can try.
Okay.
Yeah. But don't mess up your system.
And then to add to that, would you have to, for certain commands that you
Say-
so for certain conversion positions, would you have to add sudo before the commands?
Yeah. If you, that is a good question. If you, yeah, we can try that. Yeah, it doesn't really matter. Here, let's say, not this, but ls, well, cat, sudo cat, and then which one needs sudo? We can practice that. For example, ls usr bin. No. Cat not bin. VL let's see what it is. VL there, so we can see log. There are some logs, and let's see. I wanna read the. Maybe put log. There is no. Okay. Put the log. If I want to see tail 10 lines from put the log, okay? Then permission denied. So I want to do sudo and then you can send it to log.txt, my home, because I am my home, right? And then you can do change that file log.txt. No, let's do copy log.txt to log2.txt, and that is subshell. 10 for reading, no such file or directory.
I think you need a dash before the number.
Oh, yeah,
I have the same issue with it.
that is correct. So when I do this, I have a log.txt, I have a log2.txt. When I launch this, never shown anything else, right? But I got already this. So if you see cat log.txt, then you can see. By the way, there is no log. That's empty. Anyway, yeah, that works. Okay? There is a subshell. I think this explained everything. And then that is not the same as, for example, if you do that curly brace with another command. Do you see the difference? Previous one is inside here the command, right? Commands, number of commands are grouped together inside. This one is, we have a command here, but as a value, we have a curly brace and parentheses. In that case, that is not semis. This is a little different, right? If you see here, echo 1, 2, 3, then it shows 1, 2, 3. For example, I want to go to IASP, equal to OCT 7. I went out. And echo 1 to 5. 5. I have that. If I do echo 1 dot dot 5, it gives me 1, 2, 3, 4, 5. If I do, this is a little different. If you want to add the 3 and 4, for example, echo 3 plus 4, then it gives me literally like a string 3 plus 4. But if you want to compute them, see what happens. If you do this, then there is an error, because this guy already understands that parenthesis. So it is somehow group of the arguments. In order to make it as an argument, then you need to do like a variable. But there is, if it is a variable, then this should be a command. But if you say, hey, that is not the command, then you need to say another parenthesis so that it can compute. So it'll return the 7. But this is a little bit trick. So if you want to say 5 divided by 2 equals to 2 with its remainder is 1, if you want to make this, but if you write this using echo, how can you make this? Using echo. Then you need to do, I put there already the solution. So you need to do 5 divided by 2 equals, and then number 2 here, I do not want to put there hard-coded number 2, but computation of those. So that you need to have this computation, okay? Like that we have here. So you need to do $5 divided by 2. Let's stop here and see what happens. If you do then, 5 divided by 2 equals 2. That comes out, right? By having this. And therefore you can type with its remainder. Then it echo all the way to that. And then finally you need to put, what is the remainder if you divide the 5 by 2? Remainder is 1, right? So rather than hard-coded number 1, I want to put here some computation. That computation is very similar to the computation that you have here. So remainder is 5% to 2. So echo 5 divided by 5/2 equal, then we have that $sign, then this guy is ready to compute. So 5 divided by 2, then it returns the quotient only, so number 2. With this remainder, if you have a percent sign here, then it returns modulo, which is the remainder. So if I do hit enter, then it gives me 5/2 equal 2 with its remainder 1. Okay, isn't this so nice? So this will be computed. The result will be written. Back to this curly brace, I want to make this. This is very interesting. Okay, so I want to watch you. So mkdir, that makes a directory. But I want to put here, for example, if I do student 2025 to 2026, and then dash and any 1.1.9. So from 1, 2, 3, 4, 5, 6, I want you to get here. If you do within the curly brace with echo 1.5, then it returns 1, 2, 3, 4, 5, right? Similarly, if you have this mkdir with that string command, wait a minute, this may not work. If we do string, I think it should work. Let's see what happens. If we do this and hit enter, yeah. When I do this, ls, see there's that many directories created. So all student 2025, see here, student 2025-1, student 2025-2, -3, 4, 5, 6, 7, 8, 9, says 2025. After that, 2026. 2026, 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are the directory. If you see this, then they're all directories, right? They are the directories, starting with the D. So to make that, in Unix, if you want to create directories automatically without having to manually touch, but automatically, then you have to do that. What is the command? This. This is very handy, right? mkdir, whatever the literal that you put, followed by, you have to follow by immediately with that curly braces. And then if you use the dot dot, then continues, right? Increment. Same thing here. No space in between anything. Curly brace 1.9, then increment from 1 to 9. All combination of those. Once you have that, if you want to remove, because you already created, right? Oh, I do not want to do this. How can you do that? There is command that I made here, right? So what you need to do is remove rm, remove minus r for recursively, and f file start with student, anything start with the student, then all will go away. So ls, they all go, right? Create so many directories at once and remove them all at once. Very strong, very powerful Linux command. Okay, today to here.